Okay. Hi. Wake up late?
It's just the way my hair goes.
All right. This combined with the previous lesson, they're a pretty big part of calculus. Challenging, difficult, takes practice, and so because of that, tomorrow we'll practice again on what we're about to learn. But let me review what you should have learned in step 59 if I did my job. All right? If the question says find the area, then they're asking for a geometric area that should be positive. Yeah? This isn't on your notes. This is previous, just review. Okay? You make positive by making sure that the rectangles, remember the whole idea of all our integrals is that f of x dx represents heights of rectangles and bases of rectangles. And so we can make sure we get a positive answer by making the heights and bases positive. We make the bases positive by making sure that delta x is positive, in other words, going from left to right. If we go from left to right, then we'll take a change in x that's a positive one, and that'll be positive. We make the heights positive by either using the y if it's above the axis, or using the opposite of the y if it's below the axis. So, for example, if the question said find the area here, then you would say use the opposite of f from A to B, yeah? But here, f is already positive, so I'd use just straight up f from A to B. If you get multiple regions, then you might need to take multiple integrals. If I were doing this without a calculator, then I would do one integral from A to B of normal f, and then one integral from B to C of opposite f, or I could actually take that negative out front and say subtract. Okay? Now, if you're doing this problem with a calculator, you actually have two options. You could do it the same as above and do two integrals. But when you have a calculator, you also have the option of, because the calculator does numerical calculations, it can also handle this by using absolute value. Now, if you were to take the absolute value of f, then it would rewrite the function looking more like this, yeah? And so then you could just do a straight up integral from A. You wouldn't even need B, because I don't care where it's zeroed out. It's the total area is enclosed from A to C. And so if you had a calculator, you could do it in one integral by using absolute value. You with me? Is that all coming back to you? Okay. Sometimes also there aren't natural x-intercept endpoints that make the region. Sometimes they give you kind of an arbitrary region. They say find the area between the axis and f on 0 to A. Well, in that case, then you just go from 0 to A, and f is below or above the axis, so I wouldn't need to negate it. I just slap an integral from 0 to A. Yeah? This you would have to do a little bit more. You'd probably have to find the intersection point and go normal from 0 to B, and then opposite from B to A. So, tracking that. Is that all? Review. Cool. Now, these are all type 1 problems because one of the parts that make the region is the axis. Today we're talking about what if the axis has nothing to do with it. What if it's just two curves that make a region and it has nothing to do with the axis? So that's the topic of the day. Area between two curves. All right? Now, this can be simple, but sometimes very difficult. So let's walk through some gradually progressing harder and harder problems, and we'll do some with calculator as well. So here it goes. Am I recording this? Did I hit record? Did that say record? Man, I'm having trouble. Yes, it is. Okay, cool. Yay. All right. Find the area between the parabola and 2x plus 5. If possible, I strongly recommend that you graph it. If you know what the graph looks like, use the graph to help you. It adds information. So x squared plus 2, for example, you know, is a parabola shifted up 2. So something like that. 2x plus 5 is a line with a intercept, the y-intercept of 5 and a slope of 2. Together then, those curves come together to enclose the region. Now we're going to find the area of that region, just as always, by summing all these rectangles. Lots of rectangles, paper thin. All right then. So talk to me. What do you think in terms of, now we add all those rectangles by an integral, right? So what's the first thing we're probably going to have to do? Define the heights of the rectangles. Okay, there you go. Okay. So, get a positive area by making the base and the heights of the positive. Cha, cha, cha. The bases will be positive if we go left to right, but we first need to find the intersection points. Because the start and end of the region are here and here. So we're going to need to find those intersection points. Let's just do by substitution. Or, substitution, not elimination. These intersect where they are equal to each other. If we move everything to one side, we get something like x squared minus 2x minus 3, if I'm not mistaken. That is factor. How does it factor? X minus 3 and x plus 1. So your intersection points are 3 and negative 1. So right away, we know that the limits of integration need to go from negative 1, the lesser number, to positive 3, the upper number. Yeah? And we're checking with our picture as we go to make sure we're not making any dumb mistakes. All right. Now, the heights will be positive if we take the difference between the two y values. The height of each rectangle, this height is the difference between the y's. That y, take away that y, gives you the region between it, right? Upper curve, take away lower curve, gives you the region between it. Heights will always be positive then if you take the upper minus the lower. Because the upper will be greater, the lower will be smaller. If you take upper minus lower, you'll always get a positive number. So in this case, the difference between the two y values will be the upper curve. Is the upper curve the line or the parabola? The line is on top. The line has greater y values. So we're going to take the line's y values minus the curve or the parabola's y values. And for Pete's sake, please use parentheses. The whole line minus the whole parabola. Right? All right. We've got the integral set up using our rectangles and our intersection points. Actually, that's right there. Now, I think I would be better off taking a quick cleanup step. If I were to distribute the negative, then I'm really going to integrate 2x. That 5 will actually become 5 minus 2 once you distribute the negative and combine like terms, yeah? So 2x plus 3 minus x squared. Let's integrate 3 terms rather than 4. You with me? So if I integrate, what's the antiderivative of x squared, or 2x? Shoot, I just told you. X squared. What's the antiderivative of 3? 3x. And what's the antiderivative of x squared, or negative x squared actually? Negative 1/3 x cubed. From negative 1 to 3. All right. That's the first part of the fundamental theorem of calculus. To evaluate a definite integral, you take the antiderivative, and then the second part is evaluate at the upper minus evaluate at the lower. So when I put in 3 first, I get 9 plus 9 minus 27/3. Correct me if you disagree. Negative 1 evaluated is 1 minus 3 plus 1/3. Sweet. All right. What does that first set of parentheses come out to be? Yeah, 9. Back here, we get a negative 2, but minus a negative 2, yeah? So plus 2 minus a third. Correct me again if I made a mistake. But at the end of the day, 11 minus a third is? I know 2. All right. Are you with me so far? Okay. You tried it. Find the area between those two without a doubt. How we doing? All right. I just All right, are you getting 64/3? Or still working? Still working. Okay. First check your intersection points. Do you have intersection points of 2 and negative 2? Okay, you gotta have those two, write the limits of your integration. Then did you set up the integral property using your intersection points, and you get the heights of the rectangles? Don't worry about that, just ignore the axis, okay? You're gonna get a long segment by taking a positive minus a negative, you're gonna get a big, long, positive height, okay? Upper minus lower then is the downward opening parabola minus the upward opening parabola. So you should have, with parentheses, 4 minus x squared for the upper, minus x squared minus 4 for the lower. If you combine like terms before integrating, you'll save yourself some work, so hopefully instead you're integrating 8 minus 2x squared. Then check your antiderivative, 8x minus 2/3 x cubed. If you're up to that stage, then it's just your arithmetic. After that, 64/3 is what you get. Your answer should always be positive. If you have, I'm going to say this over and over again because this is going to make me crazy, but if you get a negative answer, you don't bust out the eraser and just change the answer. You go back and say, why did I get a negative? I did it wrong. All right, so do not just change the answer. Don't just do some lame, slap an absolute value on it, garbage. Go back and find why you got a negative, because you should not get a negative if you set it up properly. Yes?
How do you know which one's upper and lower again?
So that's a great question. If you know the graphs, that's why the graphs are so handy if you know them. If you know the graphs, then the visual will tell you what's upper and what's lower. The hard part by far, and this is probably what you're alluding to, if you don't know what the graphs look like and you don't have a calculator, then you're going to have to find an intersection, the intersection points, and then you would actually have to do some kind of sign test between them to see F versus G and which one has a bigger Y value. That's how you know which one's upper and lower. That's a good question. And we'll build up to that. We're not ready yet. Okay? Go to the next one, please. This is a bad problem I did when I wrote. So would you change the second function? Instead of the parabola I gave you, change it to y equals 3 minus x squared. This will be a better problem. It'll be one area instead of two, which we're not at yet. I just don't know that's the. All right. Now this is with the calculator. So you may get out your calculator. And the first thing you no doubt will do is graph it. Graph both equations. And hopefully your graph will look something like that. As much as I appreciate you watching me do it, that's not going to be the same as you doing it yourself. So you really should get out your calculator and practice this. Certainly, this doesn't require you to be able to tweak your window, but it is definitely the case that sometimes the graphs will not fall within the window, and you'll need to zoom out or find the intersection points by zooming out first. Okay? Zoom fit usually works, but not always. All right, so this isn't a standard window, so you should see pretty much what I've got there, yeah? All right, so after you've graphed it, what do you reckon we're going to need to do? Find the zeros. The zeros are the intersections. Intersections. Okay, so find the intersections. And you're going to definitely want to store the x values as we do that. Okay? So once you get the leftmost intersection point, I'm getting the x of negative 1.596. How about you? You want to store that to, I'm just going to use A. Then find the other intersection point. Once you've stored it, it should be dark and highlighted. And for the second one, I'm getting 1.11 something or other. Do you agree with my intersections of negative 1.596 and 1.1? Cool. Okay. Now, in terms of what we report on our paper, we would communicate to 3 decimals the intersection points. Negative 1.596 for the lower bound, and 1.118 for the upper bound. All work should show 3 decimals or more, not just the final answer, but all work in between. So those need to have 3. All right. If the problem has y's for the name, then it is not okay in your integrand to call it y minus y for obvious reasons. That just means nothing. Okay. You cannot use the function names if they use y. You have to actually write the functions themselves. But if they call them f and g, which they did right here, sorry, if they call them f and g, feel free to write f and g in your work. But these were called y, so we cannot set up the integral using y. We have to actually show the functions. So if we do upper minus lower, what's the function we're going to use minus which? Are we going to do parabola minus exponential or exponential minus parabola? Parabola minus exponential. So our integrand should be 3 minus x squared minus e to the 1/2 x. I didn't use parentheses around each in this case because the one I was subtracting is just one term. Dx, yeah? Now that's what we would record to our paper. Even on a calculator question, you still have to show the integral you did. Now the calculator does the heavy lifting of calculating the integral. So go to the scratch pad or add a page if you're in a document, and you're going to go in integral. So shift plus from A, or whatever you called your leftmost intersection, to B, or whatever you called your rightmost intersection. And then you could type in the functions, but you could just as easily recall them. I can't remember, did I do the exponential first? I can't remember. I have the exponential is first, so I need to go F2, the parabola minus F1. Okay, so whatever order you can use a recall, which is great. It's way better than typing in that junk again. And 3.723. Now, if you got a negative there, what does that probably imply? Yeah, you switched the two. You probably had the wrong upper and wrong lower, and you forgot which one was F2 and which was F. So your answer then reported to 3 is 3.723. You can get more if you like. For example, if you give me 4, that's all the time. All right. Did that go okay? Okay. Would you try this to try one on your own? Nope. Is there one to try on your own? I guess not. Okay. Let's try 2 areas then. Without a calculator and with a calculator. Here we go. Find the total area between y equals x squared and y equals negative x plus 2 or negative 2 to 2. If you know the graph it. In this case, you should be able to tell me what the graph looks like. We know that y equals x squared is a standard parabola. And y equals negative x plus 2 has a y-intercept of 2 and a slope of negative 1, so it goes down 1 over 1, like that, yeah? All right, now at this point, you're probably saying that looks like one area to me. That's where this guy comes in. Okay, a negative 2 to 2. Now, that means you want the area between the curves from negative 2 to 2, even if it's not enclosed. Now, I still probably want to find an intersection point because I don't know exactly where negative 2 and 2 are in relation to the intersection points. So let's find the intersection points, and then we'll get a better feel for what the regions are. If I set those two equal to each other, then it is factorable. And the intersection points are at negative 2 and 1, if I did that correct. Do you agree? All right. Now, if I were to shade the region in, one intersection is negative 2, which is awesome because that's also the start of the region. So I get one region there. But if I want the area all between the two curves all the way up to 2, then I'm actually going to get a totally different situation from 1 to 2. From 1 to 2, I get this black region. So they're giving me this arbitrary endpoint rather than just a naturally occurring endpoint. They're giving me this arbitrary endpoint. Now, we do this by upper minus lower. And in the green region, what's the upper, what's the lower? What's the upper in the green region? The line, and the parabola is the lower. But in the black region, what's the upper? Parabola, okay? Now, because I can't do all that in one integral, I'm going to have to do it in two integrals. Two integrals required, and that's because two different upper minus lower situations. All right? Now, if I were to set this up then, I would have one integral for the green region, from where to where? The green region is from -2 to 1, and the integrand, upper minus lower, is the line, -x plus 2 minus x squared. Okay. Then we hand off it to a totally different region, the black region, which is from where to where? 1 to 2, and now it's a different upper minus lower. Now the upper in the black region is the parabola x squared, and the lower is the line -x plus 2. All right? Different upper, different lower. This is basically what I just wrote. Different upper minus different lower. I should read my own notes first so I don't keep repeating writing unnecessarily. But you get the idea. We have two situations. Be careful to distribute the negatives before you integrate. Make your life as easy as possible. So the first integral is -x plus 2 minus x squared. The second integral from 1 to 2 is x squared plus x minus 2, if we distribute the negative properly. When we integrate, -1/2 x squared plus 2x minus 1/3 x cubed gets evaluated from -2 to 1. The next integrand, or antiderivative rather, is 1/3 x cubed plus 1/2 x squared minus 2x. And we're going to go there from 1 to 2. All right, so we really have to substitute 4 different values in carefully. And the first value minus what we get at the second value. So when I put in a 1, I get -1/2 plus 2 minus 1/3. Now I'm going to plug in -2. I get -4/2 minus 4 plus 8/3. Check. When I plug in 2, I get 8/3 plus 4/2 minus 4. And when I plug in 1, I get 1/3 plus 1/2 minus 2. Now, it's up to you how you simplify, but I basically go through and combine all like terms. It's up to you, however. The halves altogether. There are 4 half terms. Some people would say, forget those and call them, would you prefer to simplify that and call it -2, or you want to combine all half terms? Combine all half terms. Okay, that to me is, I make the least mistakes if I just find one from each term. All right, so I have -1/2 plus 4/2, so that's 3/2, plus 4/2, that's 7/2, minus 1/2. Altogether, I get 6/2 from the halves. Okay. The constant, or the wholes rather, are there. So I'm getting 2 plus 4. Once you distribute the negative, 2 plus 4 is 6. Minus 4 is 2. Plus 2 is 4. 6. 2 plus 2 is 4. I get rid of 4. I'm good with 4. All right. Last but not least, the thirds. -1/3 minus 8/3 is negative 9/3. Plus 8/3 is negative 1/3. Minus 1/3 is negative 2/3. So let me make sure I did that right. Negative 1/3, negative 9/3, negative 1/3, negative 2/3. I think that's cool. Okay, so this is what? 7 minus 2/3. If I take the 6/2, make it 3, and add it to 4, 7 minus 2/3 is 6/1. Okay, not arithmetic to screw up. Now, these are going to happen on an AP free response, and it's usually part A of B, C, and D, or B and C. Actually, they're usually A, B, and C. If you're pressed for time, you would get that definitely done and that definitely done, because they take practically no time. And if you're punched for time, then you would probably leave all the arithmetic for later, because it's only going to be worth 1 point at most. It's mostly conceptual where the points are, right? You try, please. Would you find the area between y equals e to the x and y equals 1 on negative 2, 2? Do not use your calculator. It's a crutch that you do not need. You know how to graph y equals e to the x, and you know how to graph y equals 1. Go. We have 2 days on those Friday, Thursday, Thursday, but if you need more time, let me know. So hopefully you're getting the data center at the y-axis at y equals 1. The antiderivative is easy, huh? You can see, we'll gradually build up to this, but there could be a lot of chances for use of those techniques within these problems. So your technique has to be solid. In this case, the antiderivatives are pretty easy. I'm getting something like -2 plus e to the negative second plus e to the second. How about you? Minus which one? A, the last one. Okay, so you're plugging the lower limit into that, so it's e to the 0 minus 0,
Oh,
right?
yeah.
Okay. And e to the 0 is 1. Okay, so the temptation, the common mistake on such a problem is people think, oh, I don't need to put 0 in, that's just going to be 0. No, not true. Sometimes when you put 0 in, you get something, like an exponentials or cosine. All right, so take the time to actually put it in and verify, and hopefully you'll get something like that. Did I get a positive answer? Better be positive, is it? What's e squared about? 9-ish. Okay, so is this positive? Yeah, positive. Okay. All right. Last but not least, calculator. 2 regions. Would you put those 2 regions in? X cubed minus 4x plus 2. X cubed minus 4x plus 2. And 1 plus 2 sine of 2x minus 3. 1 plus 2 sine of 2x is it 2x plus 3 or minus 3? Minus 3. Thank you. Oh, baby. Okay, thank goodness we have a calculator because, oh, darn it. I didn't do that. Okay. I just don't want those, whatever. Oh, so busy. All right. You with me so far? I'll give you a minute to get those in. All right. So it looks like I have 2 regions. And I could, like I do by hand, write 2 intervals. One for the different upper minus lower cases. But when you have a calculator in your hand, you can do it in one by using absolute value. You can use absolute value and do it in one, right? So you could go 2 integrals like no calculator, or you could do it with 1 integral and absolute value. Now the absolute value is going to handle the upper minus lower, it doesn't matter because I'm going to take the absolute value of it, it'll make that height positive even though in one region I'm using the wrong upper. So the good news is it doesn't even matter which you use for the upper and the lower. If you do 1 integral and absolute value, then you don't need that middle intersection point. All you need is the very left and the very right in intersection points only. Okay? So if you found the left and right intersection points, let's go in. And okay. I'm getting negative 2.297 for the left intersection point, yes? I'm going to store that to A. Go to the very right intersection point. And it's maybe between... Hi, how are you, dude? We're doing a little area between the curves. You want to join? 2. Did you get 2.1004 for the second? You did not? Or you haven't done it yet? That's not what you got for the right intersection point? Anybody else? That is what you got? Okay. Figure out. where you went wrong in the, that's an intersection point. Okay, so I would say something like, I'm gonna go, person reading this, from negative 2.297 to 2.1004, and to negate the possible upper minus lower error, I'm going to throw absolute value on it, so every height of every rectangle is positive. So because it's absolute value, it doesn't even matter which one you put on top. I'm just going to say, are these labeled with F and G? So I'm just going to use F minus G in here. Because they have names, you can use those names. And just throw that into your old calculator. Now that then requires you to go to the scratch pad, call up an integral, and your limits. I think I called them A to B, I really hope. Absolute value is in that catalog of functions button next to the 9. If you go to the button next to the 9, absolute value is right there. And then you're just going to call up your functions. F1 of x minus F2 of x. The order wouldn't matter because you have absolute value. And I get 6.7411. Do you agree? Okay. And the absolute value makes that a lot, does. Okay. Where are we at here? Is that the end of the notes or is there more? That's the end. Yay. Okay. What you got, sure? Sure what? Oh. Show. Oh, show 2 different ways. Let's just really quick do 2 different ways. We'll just kind of just do this on the quick real quick, okay? Just a second. So let's look at the graph. If I did this without absolute value, wouldn't I need to do this with 2 integrals? Yeah. So let's just call that inside intersection point, okay, rather than find it. The first integral would then be from negative 2.297 to that intersection point, and which would you put on top? The cube or the sinusoid? The cube, okay? So it would be negative 2.297 to the interior intersection point, inside intersection point. And the cube minus the sinusoid would be F minus G, right? Because in that region, the cube is on top. Then we add to that the next region. So talk to me about the limits of the next region. They would go from here to there. So the interior intersection point up to the far right edge, which is 2.1004. And that, the upper minus lower, would be G minus F. Now it's important that you know both, because sometimes the multiple choice, you won't see one, you'll see the other. So you need to understand that there are 2. All right? That's it. Is that it? Okay. That's 2 ways. One's absolute value, so you don't have to do 2 integrals, and one is 2 integrals. But the absolute value you can only do when you have calculus. Absolute value is very value. Okay? All right. Your not your post-test assignment, that's pre-algebra. Your, whatever this is, spreadsheet. How'd it go? Well, Lainey, I'll tell you. It's pretty great. All right. So let's talk about this. I actually screwed up during class yesterday in that I didn't read a very key word on number 1, and it is out. That word is pretty darn important. So it's not pumping oil in, it's pumping oil out. And so keep that in mind as we get to some of the later questions. Now that doesn't affect this question here. Can I just call this R of t so I don't have to write that stinking thing every time? Do you mind? Okay. So when I'm giving a rate of change, I can find an amount of change by integrating. So I think we did this yesterday, and we got an answer of 78. I'm going by memory. Yeah. Okay. All right. That one, the pumped out thing didn't have any effect. 2, though, I had an error, I think, on yesterday's classwork. If there are 200 gallons in the tank at time 0, how many gallons are in the tank at 20 minutes? Now, wouldn't that be start, not plus, but minus how much was pumped out? Yeah? And so that would be something like 200 gallons take away, not plus, like I said yesterday, which was dumb, minus how much was pumped out. And how much was pumped out is the accumulation of a bunch of rate times time calculations. I think I said 360 in class. It's not 200 plus, it's 200 minus. So it should be more like 30 or 40. What is the number? Anybody remember? 40-ish? Ish? Or 40 exactly. 40-ish? Okay. All right. Now then, write an expression involving an integral that gives the amount of oil in the tank at any time. There are 3 pieces to how much oil. The amount at any time depends on the starting amount, how much is pumped in, and how much is pumped out. Now, I don't see that there's anything being added. So in this case, there's not a 3-component thing. It's just start minus how much was removed, yeah? Now the start is not a variable expression, it's not a funny expression, it's just straight up 200. There's nothing to it besides that. But how much is removed is a bunch of rate times time calculations. It's pumped out at R gallons per minute, times a few gallons are per minute. From the starting time 0 up to any time t. Now, any time t is the end of the time interval, from time 0 to some time. Now, the idea of a dummy variable is the idea that I can't use a t there and there. That's bad math to use it for 2 totally different things. So you create a placeholder kind of variable, like x or v or u or something like that, to hold the place. And yeah, this would be x's for a while, but the minute you integrated, you would put t in, so your final answer would be a function of t, because t would go in at the end. All right? Without solving, give an equation that would be used to find when there's no more oil left in the tank. You could give me 2 possible answers here. Does anybody want to share one? There's 2 common approaches here. This gives you the amount at any time, right? If it's empty, what do you know about the amount? It's 0. So one is to say 200 minus the amount removed is 0. If the amount is 0, then there's no oil left in the tank. Another way to do it is to say, well, I know there's 200 gallons to start with. It'll be empty when it's pumped out 200 gallons. So another equation you might see is, when does the amount pumped out equal 200? And they both, you can see that if you just subtract this over, they're exactly the same. That's the same. So I think, all right. All right, it does not, by the way, this is a warning to you, especially on tests. It doesn't say to solve it. It doesn't say to find the time. It just says, write an equation with an integral. Done. We're done. Don't try and find t. It's not happening. Okay?
Good work, definitely Jaguar. Please try it. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'll throw up some answers here to the rest so you can check.
We have scheduled today as the final day to do so. If you have not completed ICAP at a prior meeting, you need to report to the auditorium for 7 hours today.
There will be no no sources of stress meeting today. My next sources of stress meeting will be on July 22nd.
If you are in or interested in Stage Christmas Musical, we will meet on Thursday this week. See Mr. Murphy for information.
Today, during 7 hours, Mitch Shipman and Austin Brothers will be here to discuss the Naval Academy. He can answer all of your questions and give guidance on how to apply to the academy. Stop by Johnson, Negative App. Tomorrow, Colorado Mesa University, Grand Junction, will be here to meet with you.
The early action deadline for Colorado State University is December 1st, which is this Saturday. Don't miss out on your college deadline.
The Colorado School of Mines Summer Multicultural Engineering Training Program is a science and engineering program designed to provide
You could put this together
underrepresented populations, including minorities, rural areas, and
into one integrated.
for other sports, legal and sports materials, articles, stop by Helpline for additional information.
Time to mark your calendars to come out and support your boys basketball teams on Tuesday, December 3rd from 5 to 9 p.m. at Chipotle on South Watford Boulevard. Be sure to mention Dublin Boys basketball when ordering or calling your order.
There's your 7. You want to check it?
Want to be featured in this year's yearbook? Send your Snapchat and Instagram pictures to the yearbook email at yearbook.jags@gmail.com before December 7th. Make sure to add your username to get credit for your sweepstakes.
Come see the Dublin State Champion Marching Band for the Parade of Lights downtown on Friday, November 6th at 8 p.m. or Saturday, December 1st at
Can I move on?
We are in need of more cheerleaders, especially for social studies and science. Please see Mr. Schmack if you'd like to help out. That's all your announcements. Have a great day.
There'll be about 10 of those on the test Thursday. So hopefully you'll do those well. We give those in class. This is -1. This is e to the 6th. We did these two in class, yeah? This was 32/3. If you did that correctly, you should have seen there's a need for 2 integrals because there's one region where it's the parabola, one region where it's the line. And then it's 5.9038 and 0.752. Get this to me by the end of the day. If you have questions, bring them in. Yes. No. I can show you, or I'll look at it at lunch. Just swing by after. Look at last year's and figure out how to change it. I can give you a rough recommendation. Have a lovely day.
There's another country that might have been good start.
I can. Real quick, just a second. Okay.
I actually was not this. Dingo ladies. Oh yeah, it's a tricolor. Yeah, it's gonna be the business of crab barbas and ponds.
Ooh. You're welcome. I do. Alrighty. Alrighty. Oh, shucks, I forgot.